The next class of structures we're going to look at in dealing with molecular geometry deals with our AXn complexes, where the ligand in this case contains both an oxygen or a sulfur and a hydrogen, halogen, or hydroxide group. So an example of this is SO2Cl2. And in this particular case, we have to determine what the central atom is. The central atom here is going to be sulfur. Sulfur has 6 valence electrons. The surrounding atoms are going to be oxygen and chlorine. We have 2 of each. Oxygen contributes 0 electrons to the central atom, where chlorine, each of them contribute 1. This gives us a total of 8 electrons, which are 4 pairs. In this case, the sulfur is going to form 2 bonds to oxygen and 2 bonds to chlorine. So we have 4 bonding pairs and 0 lone pairs. That means the hybridization is going to be sp3. Our electron domain and molecular geometries are going to be equal. And these are going to be a tetrahedron. So we can then write out this particular structure. Sulfur is going to be the central atom. We're going to form 2 bonds to chlorine and 2 bonds to oxygen. We have a neutral molecule, and the octet rule would predict this particular structure that I have drawn right here. But we know sulfur can expand its octet. So we could draw 2 more structures. The first would be sulfur with single bonds to chlorine, a double bond to oxygen, and a single bond to oxygen. Or we could have sulfur as the central atom, a single bond to chlorine, a double bond to both oxygens. So the question is, what's the formal charge for each of these? If we have a single bonded chlorine or a single bonded halogen, we have 7 valence electrons minus 6 lone pair electrons minus 1 bond. So each of these chlorines in all of the structures that are singly bonded are going to have a formal charge of 0. The sulfur in the complex that's preferred for the octet rule is going to have 6 valence electrons minus 4 bonds minus 0 lone pairs, or it's going to have a +2 formal charge. The second compound here, sulfur has 6 valence electrons minus 5 bonds minus 0 lone pair electrons. So this will have a formal charge of +1. And the compound over here on the right has sulfur with 6 valence electrons, sulfur with 6 bonds, 0 lone pairs. So this will have a formal charge of 0 as well. All of the oxygens that are singly bonded are going to have a -1 formal charge. And all of the oxygens that are doubly bonded are going to have a formal charge of 0. So this structure right here with all 0 formal charges is going to be preferred by formal charge. So the octet rule will predict the compound over here on the left, and formal charges would predict the compound I have in a square here over on the right. So this is the thought process that you should go through if you have both an oxygen ligand and the halogen's hydrogen or hydroxide.